Okay, I for some reason hit stop as opposed to pause. So let me finish what I was saying. Bridge problem, two pilings, mass on it somewhere. Choose a pivot point that is at one of the two, at a point where there is a force so that you can eliminate one of the torques. And again, it just becomes a matter of writing a torque equation. There's going to be an mg force down, there's going to be an mg force there, there's going to be a normal force up, and so that's relatively straightforward. An actually more complicated problem is probably the ladder problem, where you would have a ladder up against a wall, and remember we said that we assume that the friction here is equal to 0, and so again the forces are a normal force in this direction, a normal force in this direction, we'll call it N1, N2, we have the mass of the ladder, mg down, and then there'll be a body on the ladder, so there'll be we'll call it big mg down. There's an angle, and then there's a force of friction, and then the question just becomes, what's the minimum? Mu equals, or mu minimum equals what? Or Fn2 equals what? Or whatever. This is, again, one of these problems, though, where you want to think about the r vector and the force. So, for example, this here is the r associated with the little mg. This is the r associated with the big mg. That's r for big mg. The r vector associated with the normal force is up like this. I'll call that r for F sub n2. And so you just need to be smart about how you choose your radius vectors. In this problem, it's probably easier to think about r perpendicular, while in the problem that we did previously, it was better the sign problem. Remember, we talked about a force that was perpendicular. Last but not least, and I jokingly say this, but I probably won't bother to put it on the test, but I might, is the problem of the car traveling down the road. And the idea here is that the sum of the torques equals 0, the sum of the forces in the x direction equals ma, either speeding up or slowing down, and the sum of the forces in the y direction are equal to 0. So again, you'll play the same games. The idea here being I'll have to give you a center of mass, mg, and then I'll have to give you the two distances, and you'll have to know so I need to give you this distance here, d1, this distance here, d2, and then I have to give you a height, how high the center of mass is above the ground. So if you look at all those problems, you should be in pretty good shape. I'm actually probably not going to be home tomorrow after about noon. Got a variety of different things I want to do. But hopefully you'll find this useful. Have a great day, and we'll see you on Monday. I'm sure you guys, with this help, I'm sure you guys will do great. Have a good one. Bye-bye.